Okay, now we're going to move on to Chapter 4. We're going to talk about divisibility of natural numbers. We're going to talk about the word divides. Let A and B be any whole numbers with B not equal to 0, and there's a whole number Q such that A is equal to B times Q. We say B divides A, and we write B with a straight line down. We also say that B is a factor of A, and that A is a multiple of B. Okay. We can say 5 divides 20. Why can we say 5 divides 20? Well, we can say 5 divides 20 because in this case our 20, that's our A, and our 5, that's our B. So since 20 is equal to 5 times 4, and that 4 is a whole number. That's why. We cannot say 20 divides 5. The reason we can't say 20 divides 5 is because 5 does not equal to 20 times a whole number. There is no whole number that we can multiply by 20 to get 5. Other true statements we can make, we can say that 5 is a factor of 20. We can say that 5 is a divisor of 20. We can say that 20 is a multiple of 5. We can say 20 is divisible by 5. It's really important to get all the language down. 5 is a factor of 20, 20 is a multiple of 5. 5 is a divisor of 20, 20 is divisible by 5. Now this divide is either a true statement or it's a false statement. We don't say an answer. Okay, so when we say 5 divides 20, that is true. When we say 20 divides 5, that is not true. It's false. Okay, you really don't have a lot of options. You don't say 5 divides 20 is 4. You don't say that. You just say it's true. It's a true statement. 5 divides 20. Okay. Time for our first question. How much does my dog weigh? Last time I checked, he weighed 13 pounds. Definition of prime and composite numbers in units. A counting number with exactly 2 different factors is prime. A counting number with more than 2 factors, it's composite. The number 1 is called a unit. It's not prime, and it's not composite. We're going to list all the factors of 6. When we list all the factors of 6, we have 1, 2 is a factor of 6, 3 is a factor of 6, 3 times 2, and then there's 6. So there are 4 different factors of 6. Is 6 prime or composite? Well, clearly 6 is composite since it has more than 1 in itself. Let's use a factor tree to express 24 as a product of prime factors. Well, let's take 24 and break it down. You can start any way you want. I'm going to do 4 and 6. Then I'm going to break down 4 as 2 and 2. Once I can't break down 2 any further, except for 1 in itself, then I'm done. 6 is 2 times 3. So when I list 24, I'll write 24 as a product of its prime factors. It's 2 times 2 times 2 times 3. A nicer way to write it with exponents would be 2 to the 3rd power times 3. And so that is 24 as a product of primes. Here's a theorem for you. Simple product form of fundamental theorem of arithmetic. Every natural number greater than 1 is prime or can be expressed as a product of primes in one and only one way, apart from the order of the prime factors. In other words, each prime factorization of a number is unique. There's only one. The fundamental theorem of arithmetic says that each composite number can be expressed as the product of primes in exactly one way. We just stated that, except for the order of the factors. This is called its prime factorization. We're going to use stacked short division to find the prime factorization for 96. And the way you use stacked short division is you find a prime number that divides into the 96, and you keep dividing it by a prime number. The smallest prime number is 2. The next prime number is 3. And the next prime number after that would be 5, etc., etc. We didn't actually list our prime numbers. It would probably be good to list those. Let's list our prime numbers first. It's worth noting here that 1 is not prime. It has to have exactly 2 factors, and 1 only has the factor of itself. 2 is the only even number that is prime because every other even number is a multiple of 2, so it won't be prime. So we have 2, 3, 5, 7. 9 isn't prime because it's got another factor of 3. 11 is prime. 13. 15 is not prime. It has factors of 3 and 5. 17. 21. 19 is prime. 21 is not prime. It has factors of 3 and 7. 23 is prime. 25 and 27 aren't prime, but 29 is. We could keep going. Those are some of our prime numbers. So if we're trying to find the prime factorization of 96, we're going to use a short stack division. We're just going to start with 96. We're going to divide it by 2. And we get 48. And we're going to divide that by 2. And we get 24. And we're going to divide that by 2. And we get 12. And I'm going to divide that by 2. And I get 6. And I'm going to divide that by 2. And then I get 3. So if I count them up, I have 1, 2, 3, 4, 5. So 96 is 2 to the 5th power times 3. When I end with a prime number, I'm done. So I just kept dividing by a prime number until the number I end with is also prime, and then I've got all the factors of that number. That's the stacked short division. Now let's do the same thing for 4/16. I'm going to take 4/16. Again, you can pick any prime that will divide into 4/16. The most obvious one is 2. So 2 will go into 416 208 times, and then we'll divide by 2 again, and we'll get 104. And we'll divide by 2 again, and we'll get 52. And we can divide by 2 again, and we get 26. And we divide by 2 again, and we'll get 13. When we get to 13, we know that 13 is prime. So I can count up. 4/16 is equal to 1, 2, 3, 4, 5, 2 to the 5th, times 13. How many windows do I have in my living room? That is question number 2. And the answer is 2. I have 2 windows in my living room. Let's find the prime factorization of 36. You can use any method. I'm just going to use the tree method for this. 36, we'll start with 9 and 4. 9 factors into 3 times 3, and those are both prime numbers, so I can stop with those. And 4 factors into 2 times 2, which are both prime numbers. So my factorization, my prime factorization of 36 is 2 squared times 3 squared. Now, I'm going to find all the divisors of 36. I'm going to start with 1 and kind of get both then. So if I do 1, it's 1 times 36. And then I can go up to 2, and it's 2 times 18. 3 times 12. 4 times 9. It's not divisible by 5, but it is divisible by 6. I'm not going to list 6 twice because 6 times itself will give you 36. So that's all the divisors of 36. We can call them factors of 36. So I'm going to list all the divisors in exponent form of the prime factorization because if you notice, 36 only has 2 prime numbers in its factorization. It has 2 and it has 3. And it has powers of those numbers. So if I look at my factorization of 36, since it's only of those 2 numbers, I'm going to look at my 2 to the zero power this way, and then 2 to the, let's say, nth power. And this is going to be, we're going to call this times 3 to the nth power. So my 2 to the nth power, I'm going to go this way. My 3 to the nth power, I'm going to go this way. So I've got 2 to the 0 times 3 to the 0. I'm going to list all different possible combinations. And notice that's going to give me all my factors of 36. 2 to the first times 3 to the 0. 2 to the second times 3 to the 0. And then I'm going to go to the next column. I've got 2 to the 0 times 3 to the first. 2 to the first times 3 to the first. 2 to the second times 3 to the first. And then in my last column, I've got 2 to the 0 power times, these are 3 to the powers here, so 3 to the first, second. I've got 2 to the first times 3 to the second, and I've got 2 to the second times 3 to the second. So notice what I did. I listed all possible combinations of 2 to the nth power, 3 to the nth power, where they went up to the exponent, the maximum exponent here of 2. So let me list it this way. That gives me all my factors of 36. I'm going to list them in the same spots that I had before. This 2 to the 0 power times 3 to the 0 power, that's our factor of 1. 2 to the first times 3 to the 0, that's 2. 2 to the second times 3 to the 0, that's 4 times 1, that's 4. This is 1 times 3, or 3. This is 2 times 3, or 6. That's 4 times 3, or 12. That's 1 times 9, which is 9. That's 2 times 9, which is 18. And that is 4 times 9, which is 36. So notice when I list it out that way, I get all 9 divisors. If I look up here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 divisors. And they're all possible combinations of all possible powers of 2 to the nth times 3 to the nth, where they can go up to 2, because that was my factorization, 2 squared, 3 squared. Now notice that because my exponent was 2, there are 1, 2, 3 different exponent powers of that. And there are 1, 2, 3 different exponent powers of the 3 to the second power. So there were 3 times 3, or 9 different factors. So since there were 3 times 3, or 9 different factors, another way to think about that is there were 2 to the second power, 3 to the second power, so there was 1 more of those and 1 more of those, so that gave me 9.